Now you guys can hear me. Microphone was muted there for a second, but welcome Blazor fans to Blazor State Has Changed. It is November 23rd, so it is a day after Thanksgiving holiday here in the US. So you might notice some background noises that are a little bit unusual. We've got dogs barking down the street here, and people have family over and stuff, so it's been quite noisy today, so you may hear that stuff in the background. May have some low viewership and not a whole lot of chat going on because people are on break and whatnot. But I want to keep consistent with the show and have it every week, so I decided to do it anyway. And happy Thanksgiving to you all too, and thanks for that. Lohith, welcome back to the show. We're gonna cover some fun stuff today. I've got some news. News is a little on the sparse side because not a whole lot went on after that big 7.0 release last week. So 0.7.0 shipped last week, and now things got a little quiet. So I picked some community stuff from the Gitter channel and Twitter, and I hope these things are useful to you guys. The first thing up is by Scott Sauber. He's got Visual Studio Code snippets, and there are, I'm trying to remember, I read it's like 20 snippets at least for Visual Studio Code for Blazor development. So this is really good stuff. The Blazor, or Razor rather, built-in support, it just shipped in the last edition of Visual Studio Code, and now we've got some additional Blazor snippets as well. So thanks Scott Sauber for putting that together for the community. Everybody check it out, give Scott feedback on how those snippets work out, and we'll have to demo those on the show here pretty soon. Not a big Visual Studio Code user for the most part, but I do have it, and I'll get it updated, and we'll check it out sometime soon. So we've got that in the news this week, and we've also got an issue that I wanted to talk about because last week we introduced the cascading parameters for Blazor. So if you missed the cascading parameters announcement, check out the top of last week's show. I did a quick demo on how to build a tab interface using the cascading parameters. One thing that a friend of mine has pointed out is that when you use cascading components along with template components, it breaks things. So I just want to give everybody a heads up. Make sure you get into the GitHub issues and kind of vote up that issue. That's kind of an important one. So let's make sure the team at ASP.NET team, Steve and his group know what's going on there. So I just wanted to point that one out. And then Bruno Santos, he's the guy that's in charge of the Bionic framework and some really cool tooling over there. I spotted this on his GitHub page. He's got a demo of the RX framework being used with Blazor. So reactive extensions with Blazor. He's got a repo up there. It looks like it's in Blazor 0.5.1, but it shouldn't be too hard to recreate what he's done there and check that out in the latest version. So this is something I'm going to have to play with later on myself. I think reactive extensions are really cool. They picked up a lot of steam in the JavaScript community as Angular and React have started utilizing some of that stuff. So it'd be interesting to see how that works with Blazor as well. So nice job again, Bruno, for sharing a cool project. So this week is the final episode of Neural November. So all November I've been covering machine learning and trying to integrate that with with Blazor. We've done Azure Cognitive Services and Azure Machine Learning through Azure ML Studio. And this week I'm going to check out ML.NET. And I haven't looked at any of this so far. I do know There's a GitHub issue out on this already, so we may run into some problems trying to implement ML.NET. But that's what the show's about. We're going to experiment with this brand new framework of Blazor and see what we can and can't do. So this may fail. So far, we've been pretty successful on the show to make sure that we've completed projects. I'm a little weary on this one, so let's see what happens. As we talk about things on the show, I'm working on show notes, and I'll try to post those immediately after the show. Sometimes if the show goes long, those notes may not come out right away, but you can always find them at my website at edcharbonneau.com. And I post highlights of the show and syndicate everything to YouTube, so you can find links there after the show's done. So let's move on to some demos. Let's try to get this ML.NET thing spun up. And the first thing I want to do is not jump straight into Visual Studio, but instead, what I want to do is go to the GitHub repo for Blazor. So we're going to go to github.com / well, let's see, that's the Gitter channel here. github.com. And I'm going to fat finger this really badly. It should be github.com / ASP.NET / Blazor. There it is. And I'm going to look into issues because I want to go over what I found in here real quick. So somebody has already put an issue in this in the Blazor repo, and it says please add Blazor sample with ML.NET. So let's get a bigger view of what this issue entails. And if we dig in, people are asking for a demo, and there's a problem where ML.NET only has a 64-bit version. There's also an issue where ML.NET is it's only targeting assemblies and not .NET Standard 2. So we may have some issues with it just being compatible with Blazor in general. As of ML.NET 07, it now supports x86 or 32-bit mode, so there may be a possibility of it working now that it's been updated, but the fact that it's not .NET Standard makes me worry. So we'll try to get this going. So ML.NET, where do we find ML.NET? But ML.NET, I believe we can just type ML.NET, and I could be wrong, or they may have moved it. Let's go ahead and Google it. Here we go. So ML.NET, let's go to get started and see what we need. We've got the .NET SDK. I've already got that installed. The ML.NET packages, I need to get those. And we'll need to do some of these samples. What we'll try to do is go into some of the sample code in the docs and just spin up an ML.NET application in the context of Blazor and see what happens. So let's go ahead and add this package here. We'll get the SDK installed. I'm going to drop out to the command line. I'm just going to follow along with the docs. I didn't look too much ahead at this stuff, so you guys are going to learn right along with me. I do also in my Visual Studio have a server-side Blazor or Razor Components project spun up and ready to start hacking away at this. So let's get this console pulled up here. So in my console, I'm just going to put in this .NET. May need a new project for this. Let's double check the docs here. I kind of jumped ahead and just started copying stuff out. So we need to, this is going to start up a console application. So we're just adding a package here. So we can actually do this from Visual Studio. We don't need this console application. Let's go in. Let's put this in a DLL file for now, because I have a feeling it's not going to want to run natively in this .NET app. Even well, I'm not running WebAssembly, so let me think about this. Can I zoom my console font? Yeah, next time I bring up my console, actually, let's double check this. I'm going to fix this right now, Loheath, even though I probably won't use this today. There is nothing wrong with making this font size bigger in case I come back here. Let's see. I use ConEMU. I really like this console better than the default one that comes with Windows. So you can do nice things like that. I know you can change the font size in the actual console in Windows too, but this one has like copy paste and a whole lot of nice features, and it defaults to PowerShell for me. So if you haven't checked out ConEMU yet, make sure you give that a look. I've got a great article on how to install it and stuff. I'll post that in the show notes on how to do this. So we'll close that out. We probably won't use that for a little bit if we need it at all. I'm going to create a .NET DLL here. Heck, let's go straight into our Razor Components app and see what happens when we add this. Let's try to break things, I guess, before we try to fix them. So I'm going to go to Browse, and I'm going to grab this package name and go look for it. I could go to my console. I'm lazy. I don't like consoles. So I'm going to go look for Microsoft ML. Let's see what happens when we try to install this. Let's see if we get any errors. This will be our first sanity check. Installing, accept this gigantic license agreement. And, currently ML.NET only supports x86 and x64 process architectures. So yeah, we can't even install this on Razor Components. All right, so not compatible with Blazor at all, it looks like. So let's go back and remove this. I want to make sure it's not in that package or in that project. And we're going to have to do another project here. I wonder if we'll be able to reference it from another application. Let's do, let's see here. Let's do add a new project. I wonder if we'll be able to call into an application that uses ML.NET from Blazor. We may have to set up. I know ASP.NET MVC works on .NET Standard as well, so I'm not sure if we'd even be able to do that. Let's double check this. Let's do a new project altogether. And I was aware that this might be the case today, so if worst comes to worst, maybe we'll just build the console app. Not sure how we'd be able to integrate that into Blazor. Let's do ASP.NET Core Web App. We'll save any changes to this. It's just kind of a default starter project. Let's see if we can do a standard MVC application. I think we're going to run into the same problem. I'm thinking maybe if it does work, we can throw it in a web API and just access it there, which kind of leaves us in the same place we've been in. Try adding a class lib with a type of .NET Standard and see if you can install the package. That might be the most straightforward way. Let's do new project, or whoops, I want to add a project. Let's add, new project, C# standard. So let's see, class library for .NET Standard. Let's see what happens here. If we can add it here, we could most likely reference it there, but I have a feeling this is going to fail. So let's see what we can do here. Whoops, clicked on the wrong spot. I want to do add NuGet packages and Azure ML, or sorry, Microsoft ML. Let's see if we get that same error. That's what I'm expecting, actually. And no, that didn't blow up. So we can reference it from a .NET Standard DLL. So we did install, yeah, we have .NET Standard 203. We have ML 7.0, and we're able to do it that way. So let's pull this other experiment back up. Let's close this guy out. I don't need to save changes there. Good suggestion again, Lohith. We'll do that. We'll open, let's go to recent projects. And I'm going to grab, it's not in here. I'm going to grab the application I had originally up on the screen. Yeah, let's give that a shot. Here we go. So I'm going to go back to my Razor Components project. And in my Razor Components project, I'm going to do that exact same thing. I'm going to say add a new project. Oops. I cannot aim my mouse today. New project. And class library, .NET Standard. And let's call it ML service, because it'll probably end up being a service. And let's add Microsoft ML again. Now that we know this works, we'll go ahead and add this package here. And now let's try to reference it in our app here. So let's add a reference to ML service. It seems to be happy with that. So we really aren't executing or exercising any of the code, but we have a reference to it. So now we can actually start working on it. Let's see what we can do with it. I think what we're going to end up doing with this is there's going to be a training application, and then there's going to be the actual model. I went over this last week on the Azure ML Studio stuff. So there'll be a training model, and then there will be an actual runtime model that we can use. So let's read through here real quick. We're going to set up some data, and then this is going to define data structures. Let's see, this is going to be a prediction label. It's going to set up an ML context. So it's going to read in this data. It will create a training model and then create a prediction based on the model. So let's take this out. Yeah, so I would assume we probably wouldn't do this all in a single class library, but that's probably the way most of the demos come out. Let's go look at docs real quick. Not the docs I was looking for. There's more than this one tutorial here. I'm trying to remember. Keep learning ML tutorials. So there's that initial one. Let's look at this taxi fare prediction. Let's see if this is the one I was considering using earlier. There was one of these I thought fit Blazor pretty good. Yeah, let's try to take this guy. So this example here tries to predict taxi fares. I think this would make a good candidate for an Blazor app, because we could have a mobile website that we pull up and we see what our estimated taxi fare would be. So I think that would be pretty cool. It uses a regression model and it walks us all through it. So we're going to walk through this tutorial here. Create a console application. We're going to, instead of a console application, we're using this just class library. So we'll start with that. We need to create a data folder and then install the NuGet package. So we already have the NuGet package. We need data. So let's collapse all these down so we can focus on what we're working on. And right now we're going to build out this service. And let's add a new folder called data. I'm going to delete this class 1, or I can just rename it in a minute. I hate the fact that it drops that in there all the time. Let's see. So we have our ML package installed. The console is a trainer app, yeah. So let's see. Let me read through here a little bit then. So when we train, then it's going to save the model as a zip file. So we might want to do the console app first. I think that's kind of what you're on the same page with me here, Lohith. Do the console app first, and then it's going to train a model that we're going to use in the service DLL file. And we'll probably, so it's going to save the model as a zip. And then I'm going to evaluate the model. So are we going to end up, we're going to end up with 2 separate projects here? Is that what I'm kind of getting? I'm trying to skim through this so we don't have to read in detail on the show here. So we're going to save it as a zip. Yeah, it spits out the model. And then we have to use that model in an application. So rather than to make this too difficult, now that we know, oh really, you consume the zip file in your app. So the actual zip file is the trained model. It reads it out of a zip file. That's really interesting. I wonder if that's another output type like Onyx. So let's do a console app in here first and hash everything out here, and then we'll try to translate it over. That might be a little easier than trying to jump in the deep end. So new project, we'll create a couple projects in here. We'll get rid of ones that we don't need if we find out we don't need them. And console app for ASP.NET Core. Hey, Bruno, I just got done doing some show news and highlights, and I was talking about, I just gave a little heads up to folks that you have an RX demo out there. So I don't know if I saw this in Gitter or where, but I went over this on Black Friday Blazers, right? I've got like 1 million emails for Black Friday, but I don't remember where I saw this, but I saw you had a reactive extensions example in here. And I'll put it in the show notes. I don't remember how I stumbled onto it, but I thought it was there it is, RX Blazor. I thought this was a cool idea, and I think people should check it out. Reactive extensions are pretty popular right now. in the JavaScript world, and they've been in .NET world for just as long. So I think it's a pretty cool fit with Blazor. So I'm going to check this out myself sometime soon. I'm working on some Blazor stuff right now that I can't really talk about, but I think this will come in handy. I have to see how this all integrates with things. But cool example. Did notice it's on 0.5.1. I'm sure it's really easy to upgrade that to 0.7.0. There's not too many, I don't think there'd be any breaking changes in there. So back to some machine learning stuff here. We're going to create this ML.NET tutorial, and then we're going to move it on over to a Blazor app as soon as we can figure out how it all works. Yeah, I wouldn't worry about upgrading it, Bruno. You get these little one-off example projects. I've got a million of them. I could not possibly go through all of them and try to make sure they're always on the latest and greatest. So I wouldn't worry about it at all. So we're going to call this first one taxi model. So we're going to build out this model, and then we're going to try to move it into a service here in a little bit. So we've got hello world here. I don't know if I need to go over understanding the problem too much. We're going to predict the taxi fares in New York City using this. So we're going to take past data from taxi fares. We've got two files here. We've got training data and we've got test data. So when you do machine learning training, you kind of split this up, usually about 70% training data and 70 or 30% test data. They've already done the split for us. And it says that these data sets were originally from, and it gives you the source where they got the data sets from. So they've just gone out and split these up for us already. So we'll go ahead and download these guys. Oops. It's taking me to GitHub, so yeah, download. There we go. And is it going to spit it right out on the screen for me? Yeah, it is. So we'll do save as. I'll just throw them on my desktop and then I'll grab them and put them in my project. How about that? So we've got the first one, we got test data, training data, and then we got test data. So download the test data. Machine learning has really gotten to be mainstream in the last couple of years. I've been trying to teach developers that it's an important skill to kind of add to their toolbox. So it's been fun doing all that on the show for November. I probably won't dive into too much machine learning stuff after this, so we can focus more on building components and things in the front end. But I figured while news was probably going to be a little scarce this month, it'd be fun to do something a little outside the box with machine learning. So we'll take these. This is going to be our training data and our test data. We're going to put those inside of our app there. So now we've got that ready for our application to consume. And I lost my tutorials here somewhere. When I was downloading the data, I got off track. There we go. Keep learning. Taxi fare, regression tests. All right. So we have our data. And we need to make sure we follow every step in here. So we need to do this very critical step on those files, or on the folder in solution, or on each file actually. We need to tell it to copy these to the output folder so it can find them. Copy to output directory, copy always. Make sure we set those or the application won't be able to find them and we'll get errors, and that will suck. Copy always. So those are all set now. Oh, copy if newer. I missed that one. Copy if newer is what I should have put there. Copy always will probably work too. It's just gonna be a little redundant. If no changes are made, it'll keep copying them anyway. So for performance sake, we'll go ahead and change these out to copy if newer. If you're new to .NET and Visual Studio, we're just saying when we build this application, we're going to copy these CSV files over to the output directory where the application actually runs. Otherwise, it might not be able to find the files, and we'll have to put long path names in and all that good stuff. So we're going to take and open the training data and look at the headers, because I'm assuming we're going to parse this data in. So training data, let's take a look. So here's our column headers. We've got vendor ID, rate code, passenger count, the trip time in seconds, the trip distance, the payment type. Not sure if that's relevant to what we're doing. And the fare amount. I wonder if we'll be ditching this payment type, or if that has some kind of bearing on how much the taxi fare is. It could charge you more for debit versus credit or something like that. So we'll see. The label is the identifier that you want to predict, and the identified features are used to predict the label. The data set provides these columns. We looked at these. Let's see if there's anything we need to understand out of this I didn't go over. The rate code. That's probably something we need to look at. The type of trip is a feature. So I could see how that might affect the price. The passenger count, I think that's kind of understandable. The amount of time, we definitely... at that moment, you won't know how long a trip will take. So the trip time is not a feature. You'll exclude this column from the model. So we don't know how bad traffic is and all that stuff. Distance is going to be a feature for sure. Yeah, see, I thought about this one. The payment method, I said debit or credit, but cash or credit is a feature, because if you're paying cash, you might get a small discount, or they may charge you a little bit more for a credit card. And the fare amount is going to be the label. So feature is, if we're going to go over glossary terms for machine learning, feature is something that is going to affect the output, and then the label is the column or data point that we're trying to predict. So the label in this case is going to be the fare amount. And then everything except for the time in seconds is going to be a feature. So we're going to end up just ditching this time in seconds at some point. Create the data classes. Right-click, add new item. In a new class, call it taxi trip CS, and add the following using statement. So we're just going to build a POCO object, it looks like. So let's come into our model and say add a new item, a new class, and we'll call that taxi trip. So this is going to be a POCO object for our taxi data. So we've got some data annotations here. Looks like those are probably going to be part of the ML runtime. Let's see, we need to do public class taxi trip. System.component.data annotations. Let's make sure that there's not another one inside, another class inside of this first. So let's add our using statement. And did I forget to add? Yeah, I didn't add. While I was busy messing around with this stuff earlier, I forgot to add a reference to that in our package manager. So in dependencies, manage NuGet packages. And then once again, we'll add Microsoft ML here and install that to our console application. So again, we're going to sign our life away, accepting license agreements that I haven't read, and we're good to go. So now, yeah, that's why I control clicked here a minute ago. I don't know if you guys noticed that, but I control clicked on column to see if there was a class to add, and it was trying to add system.data annotations, and I had a feeling that might be there might be one already implemented in this using statement here. So inside of Microsoft ML runtime, if we highlight, there's a column attribute class already inside of this. So that would have probably been a bad thing to add the system.data annotations there instead. So now this is going to allow us to map CSV data to these data points, I'm assuming. So let's go back. Oh, I just accidentally opened Visual Studio Code. Let me get that out of the way. My aim is terrible today. I need to go play some Counter-Strike to kind of hone in my targeting skills with my mouse cursor here. I need to take a day off to actually play some video games or something. It's starting to show. We also have our taxi trip fare prediction, and this is going to be our score column. I'm assuming this is an output of some sort so we can test. So we'll probably build out all of these columns, and then we'll have a column called score, and then we'll run that as to validate our tests. So fair amount is going to be that output. Taxi trip is the input class. Yeah, that's kind of what I explained. The column attribute specifies the indice of the CSV data, and then the trip prediction is a single field fair amount. So this is in case the regression task score column contains a predicted label value. That's kind of, I think I'm on the right track there. Define model paths. Add the following using statement at the top of the program CS file. That is a lot of using statements. So we're going to be using system.io. We're going to read those CSV files. We're using Microsoft ML Core Data, Microsoft ML Runtime API, Runtime Data, Transforms. So these are all tools to manipulate the data that we read from those CSV files. So we'll go into Program CS. We'll drop all of these using statements in. And at this point, we're still on Hello World. We're not actually doing anything yet. And that's what we're about to do, is actually build the application. So create three fields to hold the paths where the data sets are. So we'll get this. So right above the main method in here. So we have our paths to our data. So we have train data path, test data path, and model path. So we're going to read this data. We'll probably do some transformations on it. Then we'll run tests against this data, and then finally we'll output the model as a zip file. So that's what those are for. And then we just have a field called text loader that we're going to probably populate some data into. Yeah, text loader is used to load and transform data sets. So that's what that will be for. This is all pretty straightforward so far. Initialize variables. Create a variable called ML context and create a new instance replacing hello world. So we'll do that next. So we're going to take this hello world out, and in place we'll set up an ML context. And looks like we have a seed value that we could set here as well. So we could set a random seed if we wanted to here. And they're setting that to 0 for now. Let's see here. Next, set up the data loading initialize text loader global variable. And we're going to use a text reader. Create text reader using a text reader, pass the context, so forth. Okay, let's just copy this here and we'll be able to figure this out. So we're going to populate text loader and we're going to say ML context data text reader. And I'm assuming we're using this text reader, ML context data text reader, because this has our column attribute. The column attribute and everything, it recognizes these, so it's going to help us read a CSV file. So it's nice to note there that with ML.NET, we don't have to have our own arbitrary way of reading data out of a CSV file. It actually provides a text reader for us because they know this is one of the standard ways to get data into a model is through a CSV file. So they've included a library for us in a class or method to do it. And there's some helpers in here that specify what columns are and whatnot. So we can set up a separator. This is a CSV file. It has a header, as we saw in this file here. This is the one we're talking about. So there's our header. So giving it this has header equals true is going to instruct the code to kind of hack that off the top or ignore it. And then it's going to set up columns. So we have a new text loader column, and we're just setting up metadata here basically. So we're saying vendor ID, rate code, passenger count, and so on. It's interesting to see that we're loading the distance in here. I'm not sure if we would be able to eliminate that completely since we're probably going to drop it at the end. But for now, they have us loading the trip distance. Or wait, no, trip time, I'm sorry. Trip time we know is going to probably come out at some point. So I'm wondering if you could just skip it there. Or if you just have to read every column in the data set. Otherwise, it'll throw off the way it's read in. So we'll see what it comes up with next as far as instructions regarding that. Add the following line of code called the train method. So now that we have our data loaded, we're going to train our model. Let's make sure we're in the right place here. This closing brace is throwing me off. There it is. Okay. It's not formatting where I'd expect it to fall. Let's move this guy over a little bit. So, well, why are we lighting up? Does not exist in the current context. So I'm within my main method. Am I missing a using? No, I don't want to generate that. Let's make sure I didn't. Add the following line of code as the next line of code to the main method. Okay. So there's some kind of problem here apparently, because train is not a thing. So we're trying to call this train method, and train does not exist. Oh, we're gonna build that next. I gotcha. I'm getting ahead of myself. So we haven't built the train method yet. All right, I was assuming it was something built in. Thanks, Janiscu7. Thank you for that. I got a little ahead of myself. Thanks for the new follower. Let's see here. We got a brand new follower. Thanks for following the show. So Anon 1364, thank you for following. We're glad to have you aboard. We're hacking away at some ML.NET today along with Blazor. So we're going to train this machine learning model and try to hook it up to Blazor here shortly. Let's see, we're going to create the train model method now. So the train method executes the following things. It will load the data. It will extract and transform the data, train the model, save it as a zip, and return the model. That's a lot of responsibilities for one method, but let's run with it. So let's copy this out, and we're going to create this new method here. So that gets rid of our red squigglies, and now we have some more. So we're not returning anything yet. That's fine. We haven't written any code inside here. We're passing in the ML context and the data path because it needs to be able to read the data, and it's going to actually do all the work for the application. So load and transform the data. We're going to use a text loader, and we're going to use return an iData view. So these are all classes that are specific to Azure ML. So let's go ahead and add that, and we'll explain what that does here. iData view, it says, in ML.NET, data is similar to a SQL view. It's lazy evaluated, schematized, and heterogeneous. That's a mouthful. The object is the first part of the pipeline and loads the data. For this tutorial, it loads the data set from the taxi trip information, useful to predict the taxi fares, and used to create and train that, blah, 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 blah. So we're basically just loading the data into this specialized data view class. And it's saying this iData view is going to be something similar to like a mini SQL database inside of ML.NET. So it's a smart object that's schematized. Let's see, in the next steps, we'll refer to column names defined in the taxi trip class. And let's see, let's set that up. So we're going to do a transform. So we're reading the data, and then we're creating a pipeline that the first step is to transform the columns. It's going to copy the columns and apply, let's see, copy columns, takes a string as the input column, and another string is the output column. So it's going to do some mapping here. It's going to take a fair amount and map that as a label. So it's going to add a label to it. And again, label is the expected or the target value that we're trying to predict. Okay. So the algorithm trains the model, requires numeric fields. So we need to transform the numeric fields now. Transform those into categorical data. So vendor ID, rate code, and payment type are values that need to be transferred into numbers. So to do that, use the one-hot encoding estimator transformation class. I would have never expected to look for something called that. To figure out where that name came from. Not a data scientist, so maybe this is something that's common in the data science field, but I don't know what a one-hot encoding estimator is. So transformation class, which assigns different numeric key values to different values in each column. Interesting. And I messed it up by putting a semicolon that didn't belong there because this is a pipeline, so I don't want to end that pipeline too early. Take that semicolon out. So we've got vendor ID, rate code, and payment type. These are all going to get a transformation. I bet there's a one cool estimator. You got the one hot and the one cool estimator. Like that. Wonder if there's a one tough cookie estimator too. Let's see. Last step in preparation is to transfer all, combine all the feature columns into the features column. So column concatenating estimator, transformation class. So we're going to concatenate all of these into a feature. So this is set up a little bit differently than Azure ML Studio. The terminology is a little different than what I'm used to. So we're defining what all of our features are in the data set. So these are all features. And notice that vendor ID, rate code, and payment type are also in there as well. And they're features, but the point of these few lines here was to create numeric types out of them. And now we're saying those numeric types are features. So these are two totally different types of things, even though we're mentioning those same columns more than once. It's adding different types of attributes to those columns. Choose a learning algorithm. So there's a lot of different training algorithms out there. I don't know how many exist in Azure ML or ML.NET. I know there's quite a bit in Azure ML Studio, but it looks like we're going to do a regression task on this one. We're going to use the fast tree regression trainer, which is one of the trainers in ML.NET. This learner utilizes gradient boosting. Again, not a data scientist. I can't explain what exactly that is. I'll have to look that one up later. Or it's going to tell us. Gradient boosting is a machine learning technique for regression problems. It builds each regression tree in a stepwise fashion. So it's going to be similar to the two-class boosted decision tree that we used last week in predicting our credit score, credit application, where we scored to see whether somebody was pre-approved for a loan. So it was the same idea. Just never heard of it called that before. Again, if it's new to me, it's not that it's new to everybody. It's just I don't work with data science all the time. I find this stuff interesting, but I'm certainly no expert. So that's why we're playing with it today on the show. So we're going to add that trainer to the pipeline. And we're still not producing any kind of output yet. So I'm assuming we're going to do something in addition to this, and that is to actually train the model. So the final step is to train the model. We train the model using a transformer chain. I don't know if this, I don't think this is an Autobots versus Decepticons thing. I think this is an ML thing. So we're going to do a transformer chain based on the data set that has been loaded and transformed. So our model, we're going to call pipeline.fit data view, and that is going to transform that chain into a model. And then we want to save the model and return it. So we're going to do save model as file. We're going to pass in ML context and output the model, and we have to write this save model as file method next. So we're going to add this new save method here. So we have private static void. This is a static method, and we're just going to call and say save model as file. We're going to have our ML context and the transformer model, and that will output our file for us. Save model executes the following task. Going to save this to a zip file. So we're going to create a new file stream, and we're going to write this out to a zip file using this method here. Hey, welcome to the show. I need to change. Give me 1 second here. I'm gonna swap out of dark mode. I can't read names in dark mode on my so you can see what I'm talking about. When everybody keeps coming in, I had this set to dark mode. I can't distinguish purple from other colors on here. At least on my other screen, it's I guess it's just a bit darker on my other screen, so I can't read a darn thing. But welcome. Silent TV22. Welcome to the show. We're exploring ML.NET. This is actually a new library for the .NET ecosystem that does machine learning. So we're going to walk through this example. We're going to build it out, do some machine learning training, and we're going to then try to insert that into a Blazor application, see how that works. If it works. So we're about done creating our training model here. We're getting ready to save this out to a file as a zip file. For machine learning, just use Python. Yeah, I think you're missing the point. No, Python's actually great for machine learning. It's been used for a long time in machine learning, but I don't want to have to learn Python. I want to just learn machine learning and use C#, so that's what this is for. Azure ML Studio is also really great, and you can use Python within that if you'd like to. I showed some of that off last week, although I didn't do any Python in it. It's pretty flexible. You can do SQL, you can do Python, you can do R. So there's a lot of machine learning stuff that you can use. Or languages that you can use for machine learning. So adding C# to that stack is a nice have. I probably could pick up Python pretty quick. I heard it's very similar to Ruby, and I've done Ruby before, so I'd have to check that out sometime. But in the short term, this C# or ML.NET stuff for C# looks pretty cool. Let's see. So this is going to set up our file save. We're going to write out a console message to just validate that we've actually saved the file. So I'm not sure I like the way this example's kind of written code-wise. It seems to be a very I know it's demo code. Demo code doesn't need to be the most abstract thing, but it seems a little messy, but we'll work with it. We're going to save that file out, and then we need to evaluate the model. So we need to save it as a zip to then evaluate it. So evaluation process, checking how well the model predicts. So we're going to evaluate, we're going to see like what the efficiency of this training or this model we trained is. I've been working with WPF for the last few months. WPF gets really hard once you get down to it. I haven't done any WPF, but I've worked with XAML and C# and stuff together. XAML's not my favorite thing. So I don't know if that's the part that's hanging you up, but I prefer HTML. I've done some Silverlight and stuff like that. And I don't know, the XAML just feels clunky after a while. So in the main method, beneath train, we're going to evaluate. So we've got this huge pipeline here. I don't mind this pipeline so much. Oops, did I copy this wrong? Back to the main method. Oh, beneath the add following line beneath the train method call. Am I missing something? We already have trainers. This is the exact same line we already had there. Why did it just tell me to add it again? It did tell us to add this before, did it not? Well, how I would have skipped ahead and found that. Add the following line of code to the train method to add the fast trainer regression tree to the data processing code added in the previous step. This is the same line of code here that it's telling us to add once again here. Yeah, so you got to use what the customer wants. Yeah, agreed. Like, that's why I'm happy to not do customer client work anymore. Because customers, while they're always right, don't always make the best choices. Not that WPF isn't the best choice. I don't know. It could be. It's not something that's so bad that it's never the right choice. It could be the right choice for the thing. So I'm assuming I have this right. It's already there. I'm not going to add it again. That doesn't seem to make a lot of sense. The evaluate method evaluates the model. Add the following below the train method. Okay, so under train, we're going to add this. We're going to say evaluate the transform model. All right, so we're going to take in the context and the model, and we're going to evaluate it. Evaluate executes the following tests. So this is going to be another pipeline of some sort. Yep, they're going to set up a pipeline that loads data, creates a regression evaluator, evaluates the model, and creates metrics and displays the metrics. These things are super handy, as we saw with Azure ML Studio. So we've got the concept of pipelines. Seems to be a big part of the ML.NET system here. Add the call to the main method right under the train method call. In the main method, right under the train method call. Oops, my bad, I put that in the wrong spot. Nope. Something doesn't make sense here. Oh, right below this, we're going to call this. Sorry, get ahead of myself again. So underneath of this call, maybe I did that wrong here as well. Let me double check. Go back to the main method and add the following code beneath the call to the train method. Let me double check if we're supposed to have this up here. Main method. So we're adding, nope, that didn't work. All right, I'm confused at some of the instructions it's giving. Blah, 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 evaluate. We're gonna go find this line and add evaluate beneath it. That does make sense. Okay, so we're gonna call that evaluate method here after we create our model. Now we need to build evaluate. Similar call to the main method, not the train method. Yeah, so I think this is right. What I'm confused at is it shows this twice, and I'm not sure why it shows that twice. It may be an error in the documentation, I'm not sure yet. Or I'm also skimming really hard, so we don't have to read through all this verbatim. Next, use the model parameter and transformer. Kind of lost as to where I'm supposed to be in this. So we created evaluate. evaluate does this, but then it tells us to go to the main method and write this. Next, we'll use the model parameter a transformer to input the features, add the following code to the evaluate method. There we go. Okay, there. We're back in the evaluate method. Back in the evaluate method. Boom. We'll put that there. I'm feeling this may not work on the first try because I might have missed something. The regression evaluate method computes the quality metrics for the prediction model and specifies the data set, returns a regression evaluate result, contains overall. So if you want a visualization of this, let's get one up here. ML Studio. It's similar to what we did in ML Studio last week. If you missed that, let's just take a quick glance at it. I won't go over what everything is, but just to show what kind of like a block diagram is of what's happening, we can at least pull that up in here. All right. So when we did the loan prediction model, we've got in our training experiment, there is an evaluate model step. So this evaluate model step is what we're writing the code for in C# right now. And what it will produce, and we have a visualizer for it in Azure Machine Learning Studio, what it's going to produce is the data that makes this area under the curve, true, false, positives, accuracy, precision, all that stuff is what I'm assuming. So we'll get something that does this here, this data set that gets pushed out. So then we can evaluate how accurate our prediction is. So that's what we're building in this evaluate step. So we're going to actually write this out to the screen, it looks like. So add the following line of code to the evaluate method. So we're going to take the model and transform it into the data view, which is a internal class or interface for the ML.NET runtime. So we're going to create the predictions as a data view. And then we're going to write that out to the screen like so. And then we're going to write it out to a file as well. A lot of writing to files in this so far, which we're not going to be able to do on WebAssembly, obviously. So let's see, RMS, root mean square, is that what we're doing? Or is there a different? Took me to the definition, I don't see it. RMS. Yeah, root mean squared is what we're getting. So this is a metric that is the square root of the average of the squares of the errors. So that's what we're getting from this next step. So we're calculating root mean squared with, sorry, got off the tutorial again. Here we go. So evaluate let's see here, evaluate predictions, metrics, regression evaluate predictions. R squared is a metric of regression models. R squared takes the values between 0 and 1. The closer to 1, the better the model. Let's see, do I have an R squared in this? So I'm jumping back into Azure ML Studio, and I'm seeing if the same metrics exist here, because we're doing something very similar. So we have an F1 score. Is it recall that it's getting, let's see, r squared. I don't see an r squared in there, but we're getting similar types of r squared. Let's read up on r squared real quick. Just trying to understand what we're looking at. R squared. Relative squared. So relative squared is in regression, the evaluation metric that is the sum of all squared absolute errors divided by the sum of the distances between the correct label, looking for the variation on the correct label. I don't know if this is called something else in here. It's not evaluated in this. Don't see it though. It could be called something different in Azure ML Studio. So that's what we're creating right now. And then we also need the RMS. So let's go back and add RMS. So the root mean squared analysis. And we're going to copy that. And write that R2 score here. Using the model for predictions, we're going to predict the test data outcome with the model in a single comment. All right, so create this test single prediction method, and just after the evaluate method, we're going to create this test method. So test single prediction method does the following task: creates a single comment of test data, predicts the sentiment based on the test data, predicts sentiment. I wonder if that's a copy paste error in the documentation. There's a sentiment analysis tutorial. I'm wondering, predicts sentiment should be something else. We're actually predicting, I don't think that's a generic term, so I think that may be an actual issue. We're predicting the fair amount, so I'm wondering if that's a typo. It should be predicts fair amount based on test data. I think that's a copy paste from this tutorial here. I don't know if anybody else follows, but I think that's what I'm getting. Combines test data and predictions for reporting, and then displays predicted results. So in the main method, under evaluate, add the following code. Add a call to the new method from the main method. Right under the evaluate method call, use the following code. Predictions. All right, so under the main method, right beneath the evaluate method, we're going to create predictions. Data view does not exist in the current context. All right, did I add this to the wrong place? So add a call to the new method from the main method. Right under the evaluate method, call using the following code. I think it actually wants this. So this. All right, so I don't think that belongs there. I think that belongs here. That makes more sense. This predictions model transform, this probably belongs in there. I think those two things are swapped. No, we don't have model here. Something's out of sorts. Do we already have this line somewhere? Yeah, we do. All right. So take that out. So I'm not sure what the reference to this is for. I think there's some typos in the documentation here that we've seen today. So I think that may be one of them. I think what it's actually referring to is this line that needs to be added. Since we want to load the model from a zip file we saved, create a file stream. Immediately before calling the load method, add the following code to test single predict method as the next line. Okay, so these seem to be off. This is the one that it's explaining. While the model is a transformer, it operates on many rows. Prediction on the individual examples is a wrapper return from make predictions method. Let's add the following line. This is actually reading the file stream. All of the examples seem to be one off of the description. So, for example, the code that this line is talking about is actually the code here. And then the code that this is talking about is actually this one. Boy, this is... So the code this one is talking about is here. The code this is talking about is here. Yeah, something's off on this tutorial. So if so like here it says, since we want to load the model from a zip file we saved, we'll create a new file stream. If you look at the code example, it's down, it's not immediately beneath the description. It says add the following code to the test single prediction method. And here it's calling the test prediction method, which is what this explains up here. So everything's kind of off by a paragraph. This is explaining the code down here. And then this is explaining the code not here, but down here. This is very confusing. I know personally some of the folks involved in writing these docs, so I'll have to kind of share this info with them so they can help fix it. I'm sure they could use the feedback. Let's see. So inside of the test prediction, this is what we want to actually insert. So I'm kind of glad this is happening live, so we can see, like, if I were doing this on my own, this might be frustrating to try to follow. But at least I'm able to point out here that the docs are a little, they're new, by the way. This is all brand new stuff. So some things need to be kind of pointed out and updated. But since we're all seeing this at the same time, we can kind of get an idea of where the mistakes are. So we need to add, yeah, there's two issues open. Misleading, seems like the following directive is mistakenly duplicated. Go back to the main method. Yeah, see, that's one of the issues that I pointed out. That was this one up here. This append, this is duplicated. So that's a copy paste problem that they must have had. Looks like an update is needed. Let's see what's under here. Looking at the part, seems a different approach. I think this is something bigger. So they may not be up to the 7.07 release. So we'll have to see if we run into any more issues. Hopefully this runs when we get it done. The source code is here, so we'll be able to go grab the source code and see if that actually works when we're done. If there's some error on my part for following incorrectly, or maybe the directions are wrong. So in the predict, we want to do this. So single test prediction. Make sure I'm not skipping something here. The prediction function is a wrapper return from make predictions. Let's add the following line of code to the prediction function as the first line in the predict method. Yeah, things are getting a little confusing because this is all out of order now. So let's try finishing this up as much as possible. This is at the very end. I'm going to go ahead and jump over to the samples, and there should be, all right, so this is how it should look. So we have this, we have evaluate, and we have the prediction. Let's see if that matches up. So we have something slightly different, maybe? Nope. Yeah, train, evaluate, predict. Those all exist here. Train, evaluate, predict. Let's make sure train is the same. It might be easier to do this side by side. I'm just checking versus a completed solution to make sure we followed all the steps right. The pipeline is set up correctly, it looks like. That's all that does. Model.pipeline fit, data view, save the model, got that, return the model, that's completed. Evaluate. Something in here didn't get translated over right. So we're missing this RMS loss. I don't even think this is in the documentation. I think the line it says to write is, the instructions are there to write it, but the actual code is not. So there's some errors in the docs. There's definitely problems with the documentation. So for example, that code that I just pasted, this RMS loss, I don't think I saw this in the tutorial. Oops, I'm off the tutorial page. So the ML.NET stuff, I'm not making excuses, but it is new. Yeah, see, on the taxi fare regression page, this is all of the instructions to build the taxi prediction console application. And if I do Control F, I'm looking for this RMS loss section of code. If I do a search on this, it doesn't show up. It doesn't exist on this page at all. So there's code in the final solution that it tells you to write, but then it doesn't give you. That I was really confused when I was going through this because of it. If you look at the evaluate step, evaluate method, model, it sets up this model of quality and metrics, and then in here somewhere it says yeah, R squared. So in here we're supposed to be looking for R squared, and it says R squared is an evaluation metric, yada yada yada. That is this R2 score piece of code, which is down here. And then it says RMS is one of the evaluation metrics, which should have been RMS loss. So it looks like, again, this piece of code here should have been this R2 score. So this code block should actually be up here. And then this code block should read RMS loss. So we're missing an entire piece of code there. So we've got some bad instructions. I'm going to give some feedback to the ML.NET team so they can fix it. It's a potentially great product, so we don't want people to get discouraged by not being able to build these things using the tutorials. Test single prediction should say high transform model, sets of a placeholder. We load the stream. Prediction, make the prediction. And then we need this. This is where this belongs. I got confused with where that was supposed to go because of the instructions. So we're going to take the sample and we're going to take one taxi trip, bounce it off of the model and see if it predicts the correct fare amount. And then prediction equals that one trip. And then we'll write this out right here. And this is potentially where we would use this in our Blazor application. We would do a single item prediction like this. Save model. I think we got that. I think this all checks out now. So I think this is all how it should be. Let's see what happens if we try to run it. I got to set this as my default project or startup project. Let's see. I don't think I have a read string console.read in here, so this may fly by and we may not be able to see it. That might be another issue. So it is thinking, not sure what it's doing. Right, there we go. So it saved the model. So it was training in that time. All right, that's what I thought was going to happen. So let's add some more outputs in here so we know what's happening. We need a little bit of a log type of thing going. The evaluation happens. Let's do this. In our main method, and let's see, is this in the final that they had? Do they have more logging to explain what exactly is happening? In program main, no, there should be. There is here, create and train the model. Yeah, let's put these in. We need to add these additional comments in here just so we're aware of what's happening. This is on the train step. So on train, before we do model fit, we're going to put this in. So we're going to create and train the model. This is going to give us our output to tell us that the training has begun, because that's why we got that window that just went black for a while. So during this step here, during line 60's piece of code, we got a empty console, and it just sat because it was training. It was creating and training a model in that step, and that actually took some CPU time. So in that time, we had absolutely no output and didn't know what was going on. For all we knew, the app had crashed. And then we've got this prediction that takes place and that. So after everything is done, we don't even see the output because there's no console read. So let's do console dot read. Read key. That should give us that should give us the console and force it to require us to press a button for it to close. And then we can run this again. So let's do train model, and it should come up immediately with a line of equal signs. Create and train model. Then it's going to do the work. And once it's done, it'll tell us it's ended and saved. Sorry about the pause here. It's real exciting stuff to watch, I'm sure. So creating training, end of training. Training has finished. The quality metrics come out. So R2 score of 0.92. It's got an RMS loss of 2.81. I need to look those up. I'm not sure what a good R2 score is. Trying to imagine what those metrics are, how they relate. But the prediction of a fare, we have a predicted fare of $15.78. The actual fare was $15.50. So our one line or one instance of a cab fare actually came out pretty close to the prediction. So that one instance wasn't too bad. So what does it say under next steps? Because once I know what my next steps are going to be, but I'm kind of curious what this says. Understand the problem. Oh, nope, that's next steps would be the iris clustering. We're not going to do that one. We are instead going to see how can we implement this in with Blazor, if at all. The training portion. So let's talk about Blazor. Let's talk about what's happening in this ML example. What relates to application code, what does not. We don't want to have a training model in our client application. Whether that client runs in Blazor, in MVC, in WPF, doesn't matter. We don't want a training model in our application unless the application is, the whole point of the application is to train ML models. For all intents and purposes, what we'd probably want to do is take in several data points and predict something and then have an output. The training process doesn't need to be part of the app. So if we look at all the code we have in main, we have the train. So we wouldn't want this part. Train actually produces, where's that train method at? We'll do a little, oh, sorry, it's right here. This whole thing we don't want in the application. This is something we would run from time to time. Depending on your use case, that time frame would be something you would have to decide on. But you would say maybe once a week you collect new data and run it through the trainer and retrain your model. You know, and speaking of taxis, so the evaluation we're doing is a taxi training model. So you could take the input of the CSV and show the training progress and then show the result. And I'm trying to speak in the context of if I was building an application that was, say I have an app on my phone, I want to pull up my phone, maybe enter a couple points of data like where I am, where I'm going to go, and it tells me what the estimated taxi fare is. That's more of where I'm thinking. Where I'd use that in like a Blazor app, for example. But I'm kind of explaining here that this whole training process is something that you wouldn't do every single time you run a query against the model. You would build this on a time frame basis and retrain whenever you see fit. So I might take, you know, the taxi fares for a given week and retrain every week or something. And then the evaluation process is part of that. And then testing a single prediction is actually the part we would want to implement in our application. So let's take a look at this. So it is taking a file stream and it's loading in a model path and it's pulling in that zip file. So model path, if we look at model path, that is exactly what I said, the zip file. So model.zip is being loaded in. So under test single prediction, we pull in, let's just put this in, let me close out my console. Let's make sense of this guy, and we're going to say loading model.zip goes here. After we load the model, we do prediction function, make prediction on a taxi trip using the taxi trip fare prediction in the context of the model. So let's see, taxi trip fare prediction is, okay, this is the output. All right, so what this line of code says is make a prediction based on a taxi trip, which is our input data, and give me a taxi fare prediction. So this is make a prediction, input, output. So it's calling, for all intents and purposes, you could look at this as a func of taxi trip that returns a taxi trip fare prediction, like that. And this func would be a function that does some machine learning, applies a machine learning model to the data. Okay, so that's kind of the same idea. It's a little more complex than just a single function, but that's what it's doing. That's a way of explaining it. So this is our input parameter, that's our output parameter, and then our ML context is the entire model that we trained. That's able, so the ML context is actually, if you think of it in the terms of a function, it is the function. Okay, so you could think of it like that. You could think of it like that, where the ML context takes our data, our taxi trip data, and crunches the numbers and gives us that taxi trip return back. So that's kind of the idea. Let's see, and then we're passing it in the actual trip. So this is, if you think of it in the context of a function, this is the parameter that's going in, and we call prediction function predict and pass in that data, and then we get our data out. So this whole bit right here is actually what we would want to put in our Blazor application. This is what we want to utilize in our Blazor app. We can't do file I/O from Blazor. We have to have a way to load this somehow. I wonder on server-side Blazor if we can access a file stream and get a file out that way. I mean, I guess we could serve the file somehow that way. Let's try to use server-side Blazor. Maybe this will work. The other problem was we're calling, let's see, what other parts of this okay, the ML context is part of Microsoft.ml.context. This will not work in Blazor because of the error that we saw very early on. If you're just joining us, we tried to go straight into a Razor Components or Blazor server-side application and add ML, Microsoft.ml package to it, and it threw an error because it only supports x86 and x64 architecture. So it will not run in the context of WebAssembly, and for that reason, it just doesn't work at all. So this is going to be very similar to the solution that I came up with for the Azure ML Studio, which was to put this bit of code, lines 82 through 107 or 106, inside of a service that that we call from Web API. So this would sit behind a web endpoint, and the web endpoint would take in a taxi trip object. So we'd post a taxi trip object to the server. The server would crunch the numbers and send back a taxi fare prediction. So we'd have to put this in a web API endpoint. We may be able to load it as a service. And in Azure, or sorry, in Razor components, we can give that a try and see what happens. We need to do, let's see, new ML context. Let's see. We need to build the ML context too, because that's part of, let's see, ML context is just simply setting up the data reader. I wonder if we need this as well. Text loader. This explains the data coming from a data set. I don't know if we actually need that part of this either. So I think all we need is our zip file and this code here. Let's see what we can do with it. So in our application, I have a server-side Blazor app. I have the server, which just bootstraps the application. I have an empty ML service, which I was going to use earlier. I'm going to use that now. And then we have our taxi model. So this actually produces the model. So let's do that. Let's take this ML service. Let's build a service component, and we'll take the service, and we need to get the zip file from this training application here. So current directory data model. Is it? Let's see. Model.zip. Why am I not seeing model.zip in here? Do we have hidden files? We do not. It's going to be under debug, data, model.zip. All right. So I'm going to be, instead of setting up some kind of like pipeline to copy this file, I'm just going to, quick and dirty, just copy, and in my ML service, I'm going to paste this. So there is our trained model. So let's actually rename that. So this is our trained taxi model that we're going to pick up. We're going to load this guy in. We're going to do a prediction. So we need to steal some code from our single test prediction. Let's grab this guy. And let's go over to our class 1. We're going to rename this guy in a second. Let's call this taxi prediction. And we're not going to take in an ML context. We'll go ahead and just build one right there at the top. And let me check my dependencies. And in my dependencies, I have Azure ML. So we've already got that added. Let's see, this is public class 1. instead of that, we're going to put this inside the class. Let's call this taxi prediction, and then we'll call this get trip fare. So we'll say get trip fare. Instead of static void, we're going to return a taxi trip fare prediction, which we don't have the objects for in here, but we'll make them available here in a second. We need to add some references in here to get rid of some of these bad squigglies. We need to produce an ML context. So we're going to hack this all together. Need to go over to our program CS here. We actually should have like some kind of common folder between these two, or common project between these two. What I'm actually going to do here is just add a reference to taxi model. Hit OK. That'll give me access to taxi trip and so on. So we'll do that. So now we have access to taxi trip, and we need an ML context. So we're going to new up an ML context again. From program CS, I think all we need is this line right here. So now we have an ML context. So we're going to take ML context, we're going to do model.load, and that should be sufficient, I believe. I don't think we need all that other metadata that gets added at the very beginning of this example, because this is a text loader. So we're setting up a data reader, a text reader. I don't think we're going to, this is specifically for the training, I believe. So we're not going to need that. So I don't think we need all that. I just think we need the context so we can load the model into it. I also need to rename my class. So instead of class 1, this is going to be this, and then we're getting an error here. Taxi model, why is this an error? Did not like when I added taxi model. Dependencies, add reference. I'm going to remove it shortly here. Let's clear our console windows. Error list. What I really need from it is this taxi trip bit here. So let's actually, I'm going to copy this for a moment. Don't know why it's throwing an error. Trying to reference it. I've got a lot of problems right now, so let's just try to add it like this, just to satisfy taxi trip and prediction. And then we need to do we also need to take in a taxi trip here. We'll get to that in a minute, I guess. Model path. Let's see, this actually needs to go into properties. We need to do copy to output directory if newer, just to make sure that persists in the right directories. And then we need to create a reference to it, which we have a similar line of code here. We'll take this. and put this at the top of our code here. Model path, and instead of doing data, let's just make it the root directory. Just take the current directory, which means we can just do this. I'm not putting it in a data directory. I could. I'm just not going to. Model path we have, sort of satisfying all of these things. Make prediction is not accessible. Add a using statement should fix that. All right, now instead of building up this taxi trip sample, we want to actually call this from somewhere else. I'm going to comment it out because I'm going to reuse that code in a moment. I'm going to take that away. And I'm also going to take out these console.write lines. And instead of simply varring this prediction, I'm going to return it. And get rid of the equal sign. And taxi trip sample is going to become taxi trip. And we're going to actually pass this in. So taxi trip like this, and there's all of our red lines gone. So what I've done is distilled this piece of code that we had in the training, the whole soup to nuts example that we had, and we're testing a single data point. So we're going to take, instead of doing all of this stuff, we're going to accept a taxi trip and then produce a taxi trip fare prediction from it. So we should be able to do that. I don't think we need these anymore. So we'll use this taxi trip object that we copied over. And then I don't know if we need to have that anymore as well. Hopefully that works out. And there goes all of our errors. Take all those errors away, and we should be able to build. Okay, so that actually worked. These should probably go into a shared namespace somewhere. We'll see if we can use those in our Blazor app though. So now we have our taxi prediction class. We have our taxi trip and our taxi fare prediction. So what we need to do now is see if we can access this from Blazor. We'll go to our app. Let's go to dependencies. Let's see if we can add a reference here now to our ML service. We already had a reference from very early on. I already made that connection. So it has access to that. Let's go to our index here. Let's try to do this the simplest way possible. And let's do a functions block here. Now we need to put, we need to call taxi trip fare prediction off of the taxi prediction, which is in a namespace of ML service. So we can say using ML service, and then in our functions we should be able to do, let's do it on a init. So now we're in the context of Blazor. Override on init. I really don't like the way that's formatting out. Let's move this down. Why is on init? Why is on a init squiggling up on me? Why am I getting red underscores here? Is it protected? It's protected, not public. So protected override on init. That should go away. Now let's see if I can access that function that's on our model. So we can say ML service taxi trip fare prediction. What's that method called? Or that object again? Taxi prediction. Yeah, taxi prediction dot, nope, public static class, maybe. So we don't really have to new this up because this is this is private. That's the problem. So that's fine. This is where the problem is. Public static taxi trip prediction, get trip fare. And then we need to pass in a taxi trip. So let's grab this code that I said we'd use later. Grab that out. We'll go ahead and put this on init, and we'll say taxi sample is a new taxi trip with this data, and then we should get an actual versus observed. Try to predict the fare amount. And then we'll pass the taxi trip sample here. And now this actually produces a result. So this is going to be var equals prediction equals and now we have prediction data that comes back. So we can wire up that prediction. Actually, let's move this out. This is a prediction of taxi fare prediction. So we can come up into our function and we can create a field. So we can say prediction I don't want that to be all caps, so let's do lowercase. Taxi prediction is a prediction. We don't want to var this up here. We just want to set it. And now we can say in our app, instead of hello world, oh wait, we're getting a problem here. Cannot implicitly convert type taxi trip fare prediction to, oh, taxi prediction. I got the wrong namespace, wrong object. Taxi trip fare prediction. Got the right results back. And then in this we can say, we'll just do an unordered list to keep things in an organized format. And we can say at prediction dot fare amount and at prediction. All we have in here is a fare amount. What would be nice is to have the probability, but it doesn't seem to be available. I'm not sure how to make it available off the top of my head. And I'm not going to worry about it at this point. So let's axe this unordered list. Let's just straight up put this in the h1 tag right here. Since it's only one value, that's all we want to see back right now. And then we can we'll have to wrap this in an if statement. We'll say at if prediction is null, because this will throw a null immediately if we don't do this. Sorry, if null, else. And then we can move this up into here. and we'll say loading here. Let's see if this actually works. So to sum this up, when Blazor loads the application on init, it's going to create a new taxi trip, which is something we could get from a form eventually, but we're not going to worry about it now. This is just another sanity test. I'm going to take that taxi trip and feed it into this function called getTripFare. If we look at getTripFare, this is loading a trained model from a zip file, creating a context, loading it here, predicting data that we're passing into it, and then returning the prediction results. So predict taxi trip. Just curious here, as an overload, I'm wondering if there's a prediction that gives you back the taxi trip example prediction, perform one prediction using the model for high load scenarios. Yeah, I don't see one that gives us back the probability. So that's interesting. I'll have to research that one. I don't think I'll have time for that today, but I'd like to know the probability of this prediction. So we're just getting back the actual fair value, and let's see if that works. So this is a Blazor server-side or Razor Components app, so we should be able to debug. I'm going to go ahead and fire this up in debug mode. Oh, I have the wrong project selected. Let's wait for this to finish. It's retraining a model, not a big deal. So what we're going to do is go into our Solution Explorer while that happens, and the server actually needs to be set to the default project. So when we hit run, it won't let me do that while it's running. So when we hit run, it kicks off the Blazor app instead of the training model. So we have a couple projects, runnable projects in here now. Sorry about the wait. Okay, so it has predicted. This is what we're expecting back in Blazor. So we want to see this 15.7855. Let's hopefully that copied to my clipboard. I don't know why it won't let me close this app out. Something's got me hung up. There we go. All right, so that closed out. I copied that to my clipboard so we could reference it here. This is what we expect. Oh, it didn't pick it up. It was 15.7855, I believe, is what we expect to get back. In Solution Explorer, let's go to our server and set this guy as our startup project. Run it. So IS Express is selected. It's kicking off. Let's see if it passes or fails. If it fails, I'm going to assume it just doesn't work. Come on, don't fail, don't fail. This would be really cool if it doesn't fail. And what are we getting? This is taking too long. It's worrying me. Oh, loading and crash. Oh, system IO file could not find. Oh, this might. Yeah, so this is actually a good failure. This is something I can fix. I renamed the zip file, and stupidly enough, I forgot to rename the path of that file. So trained model.zip should be here instead. So let's stop the app. Hooray for debugging. I say that kidding because that's not something you can do with the client-side Blazor right now. Really regret that not being there, but I understand why it's not. So we can rerun this. And we're up and running. And hopefully it won't take as long this time because it's not looking for a file that doesn't exist. Loading, crash, file not found. Cannot find Blazor.NET server taxi train model. So that's an interesting piece of information. So the context of environment.current directory is now, it's not of the service, but of, I should have known, it is of the server. So the server is executing the app. So we actually need to put the train model there and set properties, copy if newer. So now, try it one more time. Should be able to find the file. You just keep copying files around the system until it works. So it is hopefully loading the file. Loading and 0. Something did not work. Oh, I think I know what that something may be. And it's kind of ironic. I've done it before. And the name of the show is State Has Changed. Didn't tell Blazor that we have changed the state of that value. So hopefully that's it. Nope, didn't work that time. Let's try rebuild. For some reason we're just getting 0 back. I don't like that. Rebuild, rerun. So either there's a bug in my code or there's an incompatibility that's causing this, something. We'll be able to debug and see why. Still 0. So fair amount keeps coming back as 0. Interesting stuff here. I don't know if we can try. Let's try setting a breakpoint right before it calls state has changed. See if we can figure out what's going on. Prediction comes back. Prediction is 0. So it's calling this. So there's either something wrong with my get prediction function that's causing it to return a 0, or something's not compatible. So let's try stepping in. We get taxi trip in, data comes in. Maybe we do need those annotations, not sure. All right, so prediction function, let's see what's in here. Nothing that we can look at. There's no public in anything in there. Predict on taxi trip. Either the context isn't set up correctly. Let's try setting up the context. So the stuff I assumed I didn't need, maybe we do need. So I'm going to go back into program CS here, and let's take out the text loader portion of this. ML context data reader. Let's see, where is that used? Text loader. Looks like it's a public thing. It's used in the training. It's used in the evaluation. It's not used in the testing of a prediction. So I don't know if it's necessary. The one thing that may be different that's necessary is this column name is score, which is applied to Fairmount. Let's try adding that guy in there. So I had taken that out initially. Actually, let's copy this whole thing verbatim. I'm going to take this through this, copy, and under get, let's see, taxi trip. All right, let's try putting this in, and we'll get those columns. Even though I'm not getting it from a CSV file, some of these data annotations might have some kind of dual purpose. So let's just double check that real quick. Let's do a rebuild. Build this app back up and run it. So we've gotten pretty far. It's gotten a little bit further than I expected. And we're just trying to get that value out of there. Let's see if that helped at all. Oh, and I got another error. Oh no, that's a breakpoint. I meant to do that. So let's move that breakpoint down. Continue. Prediction is, we got it. Yes, it works. It works. ML.NET is compatible with Blazor server side if it's in a DLL file as a service. So that is pretty interesting. So we're able to process that prediction. So that was success. That is the third project that's been successful for Neural November. We've done cognitive services and Azure ML Studio, and now taxi predictions with ML.NET. So how cool is that? Another successful thing, and with Blazor, another integration that was kind of not done before. So what I'm going to do next is I'm going to package this repo up, and I'm going to put the repo up on GitHub, and I will reference the Blazor issue that I saw. Let's see here. If we go to github.com, ASP.NET Blazor, there is an issue in here for Azure ML, or sorry, ML.NET. Please add a Blazor sample with ML.NET. I will put this example on GitHub and link it here so folks can learn from that example. So this is cool stuff. We can do machine learning inside of Blazor, it looks like, or at least Razor components. I don't know how this would work on the client side because of the fact that it's loading from a file, and also the way the application is handled is different. I'm not adding, well, maybe I have to try this out. We'd have to find a different way of getting that model loaded. We might be able to pull it from an external path rather than using file IO, use HTTP requests to get it. Don't know if we'd be able to do that, but we could pull that file using HTTP client and then load it that way. It doesn't seem very efficient. You probably want to embed it in the application somehow. So it takes some thinking to figure out, but it looks like it is possible as long as it's using a server or a service. Now, another thing to think of is when we're loading, when we're using ML.NET, we're in the context of server-side Blazor. So if we were on WebAssembly, I don't know if that CPU restriction, yeah, it is a service right now. It's just not named service. It's just called ML service. But what I'm thinking is when this app loads, If this was a client-side app, this MLService.dll that is built, so if I look in this application here, I've got a DLL called MLService.dll. If this is running on WebAssembly, this MLService.dll actually ships down the wire, and it's run in mono. Right now, we're not running in mono. We're running on the .NET Core framework, or .NET. We're running on .NET Core. We're not running in mono runtime. So in here, we're on the .NET Core runtime. On WebAssembly would be in the mono WebAssembly runtime. I don't know if this DLL would operate because it's referencing ML.NET, specifically ML.runtime. I don't know if it'd work. Just don't. We could try it real quick, possibly. I could do it by adding, let's see, we've stopped running, right? We can do add. I can't because I have to figure out how to load this model. Because we don't have the model in a format that we can just feed it into this. Let me think. We could try using HTTP, and then we're going to have to do like a stream reader through it. Because we can't use file stream on Blazor, on WebAssembly. Regular old system.io will not work in this method. Yeah, we'll have to do a follow-up show maybe on all the ML stuff and do some refactoring on different applications, but there's some definite problems to overcome. One of them is getting the model in. The other is will the service execute without throwing an error is the other problem. Because Microsoft.ml requires x86, x64. So I don't think it'll work to begin with, and then we have to figure out this loading the model piece too. So I'm going to leave that as the closing for today. I'll get this up as an example. At least you can do it in Razor Components. Razor Components is the only method that Blazor can be used in production after ASP.NET Core 3.0 ships. So I think it's a good start. Also, I need to follow up on the docs team and let them know there's some serious issues with the documentation that we ran into while walking through these exercises. So I'll do that as well as soon as those folks, they're probably on US holidays. So I'll get back with them shortly on that. With that said, I will publish some show notes as a static resource. Yeah, like I said, I think we could push this zip file with the application as a static resource. The problem is reading it. You'd have to use, so let me show you an example of what I mean. New project. I can do file new project. I'm going to do ASP.NET Core web application. I'm just going to throw this guy away. I'm going to call it delete me. If we do a Blazor application, a client-side only application, okay? Let's fire that up. So there's no server layer in this at all whatsoever, right? This is all client-side WebAssembly Blazor project. If we look under Pages, Fetch Data, you'll see that weather forecasts are coming from sample data weather.json. So even a static resource like a JSON file is under this sample data folder,
and it's weather.json. It's being pulled in from HTTP. I can't do what is it called? System.io file stream to get this. So I could potentially call it with an HTTP GET. Let's see which methods do we even have available here. HTTP GET async. So we can get a string, we can get a stream. Response body is a stream. We might be able to use that. So we could read the file as a stream using an HTTP stream async. And HTTP GET might be able to do it. So it's just getting a specified URI. That URI could be a file. So we might be able to do it that way. I wish there was a better way to embed that resource, though. Just doesn't seem efficient. I mean, I guess there could be some beneficial pieces to that, because you could have a model. You could have a model up on a server somewhere that the model gets updated and the application doesn't need to be updated. It just fetches the updated model. My other concern might be data size. Let's take a look at, let's close this solution. I think that hopefully answers that statement. So static resource could possibly work, but not as simply as copying the existing code we have into a WebAssembly project. So let's go open that recent project that we just did. So see, in here we're using a file stream. So this would actually have to be like get stream async or something. Yeah, so I think that would be a possibility. And then where was I going with this? I lost my train of thought now. But I think that's one way of possibly doing it. But then there's still a concern of ML.NET not running correctly. So even this is showing some kind of warning on the dependencies. Not sure what it's not saying, but some kind of warning here. Yeah, we could try that at a future date. So I will post this. So that might be the best thing to do, is just post this up on GitHub. I'll do that in just the next few minutes. I'll get this posted on GitHub. Probably within the next 30 minutes, let's say. This will be up on GitHub with show notes for the show. And if you want to try your hand at making this work on WebAssembly, then fork the repository, hack at it, and then push a pull request up. And maybe next week on the show we'll revisit and see if we were able to accomplish that or not. So that could be something we could do. So we're sitting at 2 hours, 30 minutes right now. I think that's a good length for the show today. Show notes will be on edcharbonneau.com. So if you just go to myname.com, they'll be up here as Blazor State has changed. Today is the 23rd. So you'll see 23rd, 2018. I'll put links to GitHub repos and stuff that I mentioned at the news and some highlights to the show. So thank you all for joining me today. Not a lot of viewers today. Like I said, it's a U.S. holiday. I expected as much, but that's what replays are for and YouTube is for, which there's a YouTube channel as well. If you want to see past shows, I'm trying to get them all up there. YouTube.com. If you search for my name, everything goes under my name, so it should be pretty easy to find. There's apparently I have a lot of content up there. I'll put links to this as well, but replays from the show are going up on youtube.com, so you watch past shows there. If you need to look at some of the content from today, if you want to go hack on this stuff, you can find the replays up there shortly. So I'll work on that this afternoon, and I'll post on my Twitter account, again, by my name. I'll tweet out when that stuff goes live. So the same as everything else, twitter.com / my name. I'll tweet out to that. So follow me on Twitter, and you'll get a notification when the show notes go live. So that wraps up the 6th Blazor State Has Changed. Hopefully we'll get some more viewers on next week when the holidays are over, and we'll continue to grow this show. If you enjoyed the show, share it with your friends. Let them know it's out there. It should happen every Friday at noon now. Started at 2 o'clock the first couple shows. We're doing at noon because the shows have gotten longer. I expected an hour show. We're averaging 2.5 hours now. Plan to keep doing that as long as we have good content. Next month, I want to try some more theme ideas. So this month was Neural November. It was all machine learning. Next month, I want to do maybe a deep dive December. We'll try to go deep into different parts of Blazor, something like that. Or if anybody has suggestions on things they'd like to see, please let me know. If you go to my GitHub page, you can leave feedback there, or you can leave feedback on Twitter. Again, I go by my name everywhere, so you can find me easily on GitHub, and there is a repo out for the show. Blazor StateHasChagned show. So actually I popped these into chat here, so you can find the show suggestions there. Just file an issue and I'll try to get back to it there. If you have a show idea, show notes will be up on my website. Pop that into chat, and my YouTube channel if you want to catch replays of the show. See if we can get this up here as well. And there's replays of the show. So there's all the important links for today. We'll get those show notes up as soon as possible. Thanks again, everybody, for joining me today and hacking away at Blazor. Thanks to the chat room for all the help and the new followers. Take care, guys. Enjoy your weekend.